Okay, a car suspension has this variation of amplitude of vibration versus driving frequency with a moderate amount of damping, right? So it could be heavier, it could be lighter, right? Okay, what is the resonant frequency of the system? Well, that's the peak right there. So let's figure this out. All right, let's see. 5, 6, 7, 8, 9, 10. So that's 6 hertz. That's our resonant frequency. So just find the peak, read the graph. Sometimes I'll give you graphs like this, like that thing in the middle there. That's 7.5, right? They'll give you graphs that are hard to read. They like to do that. All right, draw a curve for a slightly higher Q factor. So this is less damping. Okay, remember that as you increase damping, the curve, the peak gets lower. It gets broader, it shifts left. Okay, but at the extremes, it's the same. Okay, at the extremes, it's the same. So this is our challenge here, right? So let's draw that little peak there, right? So with less damping, right? A higher Q factor is less damping. Let's make our peak be just slightly to the right and pointier, right? Something like that, right? You try to do this with a stylus, right? And I think it actually is above this for a wider, right? And then slightly lower Q factor is more damping, right? So we need a broader peak. It needs to shift slightly left. So let's go. Let's make our peak be about here. Let's make it broader. So let's see. Right, so at the extremes, it's the same. Okay, the peak got broader, it shifted to the left, and it got lower. Okay, so that's what they're looking for, and they'll ask you to draw these. Okay, so less damping, sharper peak, a little more to the right. Okay, and narrower, more peaky peak.